Okay, guys, we are looking at Unit 11, Lesson 2, solving equations with rational exponents. These are the same rational exponents from Unit 11, Lesson 1, and we are just solving equations. So all the same basic properties, adding, subtracting, multiplying, dividing to solve, all of that still applies. We just have this added rational exponent. So probably the easiest thing to do is go ahead and look at an example. So let's start with that easy one. I have x to the 1/2 power equals 7. So the way that we're going to go about solving this, I have to get rid of this exponent here. I want to know what just x is. The way that we do that is whatever the rational exponent is, we're going to take the reciprocal of that. And if you remember from the last video, the reciprocal just means basically to flip it over. So if I have 1/2, the reciprocal is 2 over 1, which is just 2. So I'm going to raise both sides to the second power, so I'm going to square it. And 1/2 times 2, that is just 1, so x to the first power, which is what I want. So I just get x equals 7 squared, which is 49. And just like with any equation, we want to check that our solution is actually a legit solution. So I'm going to check. So I'll plug that 49 back in. So 49 to the 1/2 power equals 7, and we're checking. So I'm putting a little question mark right there. We don't know for sure. If you remember from the last video, the 1/2, what does that mean? It's to the first power with the second root, so the square root, and the square root of 49, that is definitely 7, so 7 equals 7. So since we get a true statement, x equals 49 is our solution. So what could have gone wrong right there? What can I not take the square root of? It's a negative number. So if I ended up with a negative number trying to take the square root, or any even number on the bottom. So if it's even on the bottom, your answer can't be negative. Because we can't take the even root of a negative number. So just be looking out for that and make sure that you do check your solutions. Alright, so just a couple more examples. Let's say I have x to the negative 2/3 power equals 64. And so same exact thing, I need to get rid of this negative 2/3. The reciprocal of negative 2 over 3 does not affect the negative stays, so I want to raise everything to the power of negative 3 over 2. So left side to the power of negative 3 over 2, and the right side to the power of negative 3 over 2. On the left, negative and negative makes positive. 3 times 2 is 6. 3 times 2 is 6. 6 over 6 is just 1, which is what we want. So x to the first power, or just x, equals 64 to the negative 3/2 power. Now what's nice about this is we can go about simplifying this in any order. I can start by taking the square root, or raising it to the third power, or flipping it over, and either way I'm going to end up with the same answer. One just might be easier than the other. Like in this case, 64 to the third power. I do not know what 64 to the third power is, but I do know what the square root of 64 is, and that happens to be 8. And so simplifying the 2, I get 8 to the negative 3 power. So the 2 goes away because I took the square root. Okay, so now I really don't have a choice. I don't know what 8 to the third power is, but I can figure it out. 8 times 8 is 64, and then 64 times 8, what is that, 2, 3, 512? So 8 to the third power is 512. If you remember the negative, what it does, it's going to flip it over. So 8 to the negative 3 power, it's not 512, it's 1 over 512. And again, we want to check to make sure that this is a legit solution, so I'm just going to plug it back in. So I get 1 over 512 raised to the negative 2/3 power equals 64. The negative tells me to flip it back over, so 512 raised to the 2/3 equals 64. Again, I don't know what 512 squared is, but I should know what the cubed root of 512 is because we just figured out what 8 cubed was. So the cubed root is 8, so I get 8 squared equals 64, and that is actually true. 8 squared actually is 64, right? So 64 equals 64. That is legit, so I know that this is a real solution. Alright, one more example. Una más. So let's say I have 1/5 x to the 3/4 power plus 31 equals 6. I want to go ahead and solve. So if you look at the difference between this equation and the first two, in the first two equations we just had x with the rational exponent all by itself already. We don't have that in this case, and so just like a regular equation I'm solving for x, I need to get rid of the 31 and the number in front. So I'm going to go ahead and subtract 31 from both sides. So I get 1/5 x to the 3/4 power equals 6 minus 31 gives me -25. And to get rid of the 1/5, you can either divide by a fifth or multiply by 5. It means the same thing. I'm just going to go ahead and multiply by 5. 5 times a fifth, those things cancel out, which is what I wanted. So I end up with x to the 3/4 equals 5 times -25 gives me -125. And so there we go. Now it looks like one of the equations that we originally started with. And so I need to raise both sides to the reciprocal of my exponent. So it was 3/4. The reciprocal is 4/3. So I'm going to raise both sides to the 4/3 power. 4/3 power. Again, 3 times 4 is 12. 4 times 3 is 12. 12 over 12 is 1. So I end up with just x equals -125 raised to the 4/3 power. Be careful with this. This is -125 raised to the 4/3 power, so that negative needs to be inside parentheses because that's part of my number. I don't have just a negative chilling out front. And those of you that are going to try and be sneaky and use your calculator, this is going to screw you up every time. So make sure parentheses, 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 they are in front. So go ahead and simplify this. I don't know what -125 to the 4th power is, but I do know what the cubed root of -125 is, or we should. What do I multiply times itself 3 times? That gives me -125. And the answer is -5. So I get x equals -5 to the 4th power. Still with my parentheses, -5 to the 4th power gives me what? -5 times -5 times -5 times -5. I end up with a positive number. Negative times a negative is positive, times a negative is negative, times a negative is a positive. So I have 4 of them, so I end up with a positive, and it is actually 625. So x equals 625. Again, I want to check that that is legit, so I'm going to check it. I have 1/5, 625 to the 3/4 power plus 31 equals 6. So the 4th root of 625 is 5, so 1/5, 5 to the 3rd plus 31 equals 6. 5 to the 3rd power is 125, so 1/5 times 125 plus 31 equals 6. 1/5 of 125 is 25, so 25 plus 31 equals 6, and that is not right. 56 does not equal 6, and so I'm going to go ahead and say that 625 does not give me a true answer, And so we actually have no solution. Okay? Go back through and check my work. Make sure that you check yours. Everybody makes mistakes. Let me just double check real quick. 625 for fruit should be positive. Yep. No solution. All right, so there you go. That is solving equations with rational exponents. If you have any questions, don't hesitate to email me. Here are your practice problems. Take a second to write those down. Make sure these are going in your notebook. I will be back in, what, less than 2 weeks? Oh my gosh. Y'all miss me? I miss y'all too. Alright, so these are your practice problems. They should go into your notebook. If you have any questions, email me. Y'all have a great day.